Welcome. Today we're going to be looking at GDP, Gross Domestic Product, and PPP, Purchasing Power Parity. These are very useful concepts if we want to compare the economy of two different countries. Let's take a look. Gross Domestic Product, as you probably know, is the market value of all final goods and services produced within a country in a year. I'm not going to say so much about gross domestic product and its problems and its measurement because you can find this material in just about any textbook. Of course, I recommend that you choose the best textbook. Let's move on. The problem we want to solve is this. How do we compare, let's say, 2010 US GDP of $14.5 trillion with the GDP of Thailand, which in Thailand is measured as 9.5 trillion baht? Well, the obvious idea is to use exchange rates. And indeed, if we do this, we find that $1 is equal to about 31 baht at this point in time. So Thai GDP by this measure is approximately 300 billion US dollars. There are two problems, however, with using exchange rates to convert GDP. The first is that exchange rates swing a lot, and this implies implausibly large swings in the standard of living. So it wouldn't be at all impossible, for example, for the Thai to US dollar to baht exchange rate to swing by 30% within a couple of months, either up or down. But this just implies much bigger changes in the standard of living in these two countries than is really very plausible. The second problem is that exchange rates are more relevant to goods that in fact are exchanged, to tradables, and less relevant to non-tradables such as many services. In fact, it turns out that non-tradables tend to be cheaper in poorer countries. That's an important fact we want to say a little bit more about. Manufactured goods tend to sell for similar prices everywhere. This is the law of one price for tradables. So for example, if you want to buy an iPad, it's going to cost you about $500 whether you buy it in the United States, whether you buy it in France after you've converted the currency, whether you buy it in China, even if you buy it in Outer Mongolia, it's still going to cost you, when all is said and done, about $500. And the reason for this is, imagine that iPads were selling for $300 in Outer Mongolia. iPads are tradable. They can easily be moved around. So if iPads were selling for $300 in Outer Mongolia and $500 in the United States, it would make sense to buy iPads in Outer Mongolia for $300, ship them to the United States, sell them there for $500 until the prices equalize. The same is not true for services. Services tend to be quite a bit cheaper in poorer countries. You can get cheap haircuts, cheap cooks, and cheap house cleaners in a poorer country. This is because labor is non-tradable. Labor, at least in our world, is immobile. So for example, you can get a cheap cook in India, an expensive cook in the United States, but you don't see lots of cooks moving from India to the United States, at least not compared to the numbers of people who could move. So the exchange rate, because of this, is more closely related to the relative price of tradable goods. Tradable goods will be exchanged through the arbitrage process I just discussed until, in fact, the exchange rate makes it such that tradable goods sell for about the same price everywhere once you've done all the currency conversions. The same is not true for labor. The same is not true for service goods, for non-tradables, for immobile goods. So as a result of this, calculations of GDP based on exchange rates tend to overestimate the cost of living in poorer countries because they take into account that tradables are about the same price, but not that non-tradables are cheaper in poorer countries. This is called the Balassa-Samuelson effect, and you can find more about it by listening to the video on Bella Balassa. Okay, given this, how do we compare GDP of two different countries? Well, we're going to use a method very similar to what we do to compare GDP over time in the same country. So let's remember what nominal GDP is. So nominal GDP is just the market value of all final goods and services sold in a country within a year. So for example, if we want to look at nominal GDP in the United States in 2005, that's 2005 prices times 2005 quantities turns out to be equal to $12.4 trillion. If we look at 1995 GDP in the United States, that's 1995 prices times 1995 quantities, that's $7.4 trillion. The growth of nominal GDP, then subtracting these numbers, that turns out to be equal to 67.6%. We really don't think, however, that the growth in living standards has gone up by 67% between 1995 and 2005. Is the growth of nominal GDP over this 10-year period includes price increases as well as increases in output. So the solution to this problem is to calculate GDP in each year using the same set of prices. So for example, we can calculate 2005 GDP, just as we did before, as 2005 prices times 2005 quantities. That's again to $12.4 trillion. Now, however, let's calculate 1995 GDP in 2005 dollars. That is, we're going to use 2005 prices times 1995 quantities. That gets us 1995 GDP in 2005 dollars, and that's $9.0 trillion. So the growth rate of real GDP turns out to be 37.8%. Not bad, but not the 67% that we saw earlier. So the idea here is that using the same set of prices eliminates the effect of price changes on GDP. Let's try the same trick for comparing the economies of two different countries. So to compare GDP over time, we create a basket of goods, which is comparable over time, and we look at how the price of that basket changed over time. So we can find, for example, that a basket of goods which cost $10 in 1915, we can trace that same basket all the way through 2005, where it cost $207. We can then use that series of price changes to calculate real GDP over time. Let's use the same idea for comparing GDP between countries. We need to create a basket of goods, which is comparable between countries, and look at the prices of that basket in different countries. If we do this and we find, for example, that the price for the basket is PA in country A and PB in country B, then the purchasing power parity ratio is PA to PB. That is the number of units of country A's currency that are needed to purchase the same basket of goods and services as 1 unit of country B's currency will purchase in country B. Okay, that's kind of a mouthful, so let's give an example. Let's take a look at the most famous purchasing power parity ratio or index, the Big Mac index, which is produced by The Economist. The Big Mac is a basket of goods. It's a basket of bread and beef and cheese and onions, and also the labor required to cook these products and to deliver them. So in the United States, this basket of goods can be bought for about $4.45. In Thailand, the exact same basket, the same Big Mac, you can buy it for 70 baht. What that suggests, for example, is that somebody who earns 70 baht an hour in Thailand has about the same standard of living as somebody who earns $4.45 an hour in the United States. Notice, however, that the actual exchange rate is not $1 to 15.74 baht, it's actually 1 to 29.6 baht. In other words, if you take that 70 baht in Thailand and you convert it into dollars, you're only going to get $2.36. This might suggest, if you used the exchange rate to look at standard of living, this would suggest that somebody who earns 70 baht an hour in Thailand actually has a standard of living equivalent only to $2.36 an hour in the United States, while in fact we know the actual equivalent is $4.45 an hour. We know that the person in Thailand can afford a Big Mac, not just half a Big Mac, as the exchange rate would suggest. Well, why is this? Well, this is the Balassa-Samuelson effect. It's the fact that the Big Mac contains a labor component, and labor is cheaper in Thailand, which means that it's cheaper to live in Thailand than you would expect from the exchange rate alone. Another way of putting that is that people in Thailand have a higher standard of living than you would expect given the exchange rate alone. This is why we want to convert using purchasing power parity ratios rather than using exchange rates. By the way, you can also see that down here where it's actually cheaper to live, these tend to be poorer countries, right? While up here where the exchange rate is, you could say, overvalued, okay, where a Big Mac cost you $8, for example, in Norway, these tend to be the richer countries. Again, this is very consistent with the Balassa-Samuelson effect. So remember, we want to convert using the purchasing power parity ratios in order to take into account that some goods, particularly non-tradable goods, are cheaper in poorer countries, and we do that by using the same basket of goods in all countries. The Big Mac index gives us the right idea, but we'd really like a bigger basket of goods. After all, the Big Mac doesn't include everything. So this is what the World Bank's International Comparison Program does. It creates a very large basket of goods to try and create PPP Adjusted real GDP. By the way, when you do this, Thailand's GDP based on exchange rates is 300 billion. When you do it based on PPP, which for all the reasons we've discussed is a more accurate account of the strength of an economy or the standard of living, it's 585 billion, a larger number. Now, it's very difficult to make real GDP comparisons over long periods of time. This is because it's difficult to find a comparable basket of goods over periods of time. We consume a lot of goods today, like iPads, which simply weren't available 20 years, let alone 80 years ago. We also change our consumption patterns over time. So we consume a lot fewer horseshoes today than we did 100 years ago. But if horseshoes are a little bit more expensive today, you wouldn't want to say that that means our standard of living has gone down a lot. Goods change in quality over time as well. We have very similar problems when we're trying to make comparisons of GDP between very different countries. Let's take a look. So how are we going to make this international basket comparable? We have a number of problems. First, I'll call the rice problem. Well, rice seems like something we ought to be very easily able to compare across countries, but yet when you look in more detail, you say, well, are you comparing long grain rice or short grain rice? Brown rice or white rice? Uncle Ben's or Kismet rice? So all kinds of different types of rice, and we need to try as best as we can to make account of those differences. There's also what I call the croissant problem. For some reason, croissants are just a lot better in Paris than they are in Washington, D.C. You can go to a bakery right off the street in Paris, and the croissant just tastes a lot crunchier and crisper and yet soft inside than the one you buy in Washington, D.C. So there are quality differences which we'd like to take into account if we possibly can, but of course that is hard to do. Then there's the cheese problem, or the consumption weight problem. We consume a lot of cheese in the United States. They don't consume very much in China. So if cheese is more expensive in China than it is in the United States, that doesn't mean that the Chinese have a lower standard of living, because they don't want to buy the cheese anyway. So we have to try and take into account this basket of the goods has to be comparable across countries. So we don't want to use the U.S. consumption ratios. In fact, we don't want to use the Chinese consumption ratios either. We want to try and create some middle ground. Then there's the healthcare problem. How do you measure the prices of goods which aren't bought and sold in markets? Healthcare is a big part of GDP, and yet for the most part, we don't have prices for a heart surgery or for diabetic treatment or something like this. So in this case, we usually measure by the cost of the inputs, which is not as good a solution. Then everything that I've said so far also applies. We want to look at producer goods. You know, the welding equipment. How are you going to find comparable welding equipment? So everything I've said about consumption goods, about creating a basket of consumption goods, we also want to include in there producer goods. So that just adds to our problems. The quality of data in poorer countries also tends to be quite poor. So this motivates other ways of trying to figure out what GDP or standard of living is like. Electricity consumption is another proxy for standard of living. And you can actually estimate this. And Henderson, Storeygard, and Weil did this in a paper called Measuring Economic Growth from Outer Space by looking at the lights at night. Here's a famous picture. This is from my textbook with Tyler, showing South Korea down here. Lots of lights, lots of action. This is at night, lots of people going out to parties. This is North Korea up here, pretty quiet. You can therefore see just by looking at the lights that North Korea is a much poorer country than South Korea. You can look at this not just at a point in time, but you can actually see the lights coming on. You can actually see economic growth as it happens. In China, for example, you see literally the lights turning on at night as the country becomes richer. So this is another way of trying to get at some of these issues. So what's the bottom line? Well, the bottom line is, despite some problems, PPP Adjusted GDP, or real GDP, it's a very useful statistic for comparing countries. So we can look at the total GDP of the United States. This is in 2007, was $12.9 trillion. The real GDP per capita was 42.8. We can compare that with China, which had a very large total GDP, 8.4 trillion, almost as large as the United States. The GDP per capita, however, was much, much lower. India, even lower yet. So even though it's imperfect, these real PPP adjusted GDP statistics are very useful for comparing countries and for looking at how countries are growing over time. Thanks.